Welcome class to our new video notes on 3.5, which is solving quadratic equations by completing the square. So I do want to have you do a warm-up. So for this one, you are going to be solving. I will let you know you are going to be solving with square roots. I want you to try this problem on your own. Okay, so what you should have done is get it in standard form equals 0. So we would start by subtracting 25 from both sides. Oopsies. And then we would do our big X method, looking for A times C, B, two numbers that multiply to get these numbers and add to get them. So we would get X minus 7 and X plus 3 equals 0. Now I'm going to review, in case you're still struggling with solving by factoring. We would set each factor equal to 0 and then solve, giving us X equals 7 and X equals negative 3. Oopsies. So there are two answers. Now, what we're going to do is go over a couple of our definitions. So first of all, completing the square, that is our method, is a process used to make a quadratic expression into a perfect square trinomial. We're also going to be looking at solving with square roots because we're going to be looking at vertex form, which is y equals a times x minus h squared plus k. And we are going to look at some projectile motion problems. Those are problems that involve objects being thrown or dropped. And we're going to do one of those at the very end of this video. So, what is a set of two numbers that can be multiplied to get 36 a perfect square? I'll give you two hints, or I'll give you a hint. It's two sets of numbers. Okay, so hopefully you know that at least 6 times 6 equals 36. Well, there's also negative 6 times negative 6, which also equals 36. And the reason that I want to go over this is that let's say we take the square root of 36. Well, we know it equals 6, but technically it also equals negative 6. And so for today when we solve with square roots, we're going to bring that plus or minus because we're solving. And so the first thing that we're going to go over is solving with square roots. It has to be in vertex form or your bx term is missing. You isolate your x squared or your x minus h squared term. You take the square root of each side. Don't forget the plus or minus because there's going to be two solutions. And if necessary, keep isolating x. So what we're going to do is we're going to see how to solve the next two problems by factoring or with the square root method. So for factoring, we would have a difference of two squares because x squared and 16 are perfect squares and they are subtracting. And so we would get x minus 4, x plus 4 equals 0. Then we would take each factor, set them equal to 0 and solve, giving us, so plus 4 minus 4, giving us x equals 4 and x equals negative 4. So there's our two answers. So that's using factoring. And that only really works though if we have a perfect square. Now, if we have square roots, what we do is we isolate our square term, and then we take the square roots of both sides because the purpose of this is it cancels out that exponent. And then we get a plus minus because there's two values that's squared to get 16, and 16 is a perfect square to get 4. Now, these answers are the same. The one on the right is just combining them into one value. It's not really one value, though. Okay, factoring. So the first thing we have to do is we have to deal with the x minus 3 squared term. So we have because to factor, we have to be in standard form equals 0. And so what we're going to do is we are going to do the big X method to get into more standard form. So we get x squared minus 6x plus 9 equals 25. We can then subtract 25 from both sides to get x squared minus 6x minus 16 equals 0. Then do the big X method to get negative 16, negative 6. We would get negative 8 and 2. And so our factored form would be x minus 8, x plus 2 equals 0. And then if we want, we can use our shortcut because we're running out of room. We can get 8 and -2. So that's big with factoring. Now, factoring doesn't always work, and so this is a special case. Instead, what we can do, because it kind of looks like vertex form, we can, because the squared term is by itself, take the square root of both sides. We would get plus or minus 5, because 25 is a perfect square. Add 3 to both sides. Now, technically, right now, these are not like terms. Okay? And so what we get is 3 plus or minus 5. Well, how does that get turned into the blue answer? Well, what we do is we can take this. Now, you can either do this in your head or you can write it out. You can separate that plus or minus to be 3 plus 5 and 3 minus 5 to get x equals 8 and x equals -2. Our two answers. Okay, so that was kind of a review on factoring and solving with square roots. So now what we're going to do is we're going to go to the next page and we're actually going to solve with square roots. So for this problem, what we're going to do is we're going to want to isolate that x squared term. So we're trying to get rid of isolate that. And so what we get is 5x squared equals 30. Divide both sides by 5 to get x squared equals 6. So our x squared term is by itself. And so we're going to take the square root of both sides to get the x equals plus or minus the square root of 6. Now you do always want to ask yourself, can you simplify that square root number? Well, 2 times 3 equals 6. There's no pairs, so that is our answer. Not too bad. Okay, let's go to the next problem. Here we go. So I'm going to isolate my x squared term. So we get 6x squared equals 30. Divide both sides by 6 to get x squared equals 5. This is where we would take the square root of both sides to get x equals plus or minus the square root of 5. Well, again, in this case, 5 is a prime number, so that is our answer. Woo! Okay, next one. So for this one, we could solve by clearing fractions, but the fraction is also just attached to our variable. So instead, what we can do is we can add 10 to both sides, and then multiply both sides by 10 to get x squared equals 100. And so now that our variable is isolated, I'm going to take the square root of both sides to get x equals plus or minus the square root of 100. Well, 100 is a perfect square, and so we get x equals plus or minus 10. And you don't have to split that answer into 10 and -10. You can leave it like that. Okay, so that's where these terms, you've been missing a bx term. Those were all the examples. What we're going to see now is where we're more closely looking like vertex form. And so what we do is we're going to add 4 to both sides, which will give us x plus 5 squared equals 64. We're then going to square root both sides because we're going to have to get rid of that exponent first before dealing with what is inside of our parentheses. And so 64 is a perfect square, so it is 8. So if you're confused, the square root of 64 is 8. But we can't forget that plus or minus. And now I'm going to subtract 5. And so what we get is x minus 5 plus or minus 8. Well, because they're all exact numbers, what we can do is we can take this and do -5 plus 8, which is 3, and -5 minus 8, minus 8, which is -13. And so that's how we get those two exact answers. Okay, I'm actually going to skip this problem for right now because it goes with our next piece. Let's go here. Okay, so there's a lot going on. Do not add. We first have to subtract 10. So we get 2 times x plus 6 squared equals 2. And then we divide both sides by 2. Giving us x plus 6 squared equals 1. Now our square term is isolated, so we're going to square root both sides to get x plus 6 equals plus or minus 1. 1 is a perfect square. Don't forget that. And so from here, we would subtract 6 from both sides, giving us negative 6 plus or minus 1. And so we would get x equals negative 1 minus, negative 6 plus 1 is negative 5. And negative 6 plus, or minus 1 is negative 7. Just a little thing, the order that you put your answers does not matter. So if you put negative 7 and negative 5, awesome. Okay, so let's go back to this problem that I told you to skip. How we're going to solve it, we're going to start by subtracting 7 from both sides. So we get negative 3 times x minus 1 squared equals 12. And then we're going to divide both sides by negative 3, giving us x minus 1 squared equals negative 4. We're still going to square root both sides, giving us x minus 1 equals, well, remember from 3.1, the square root of negative 1 is I, and 4 is a perfect square, so we get plus or minus 2i. We still have that plus or minus still there, but that is our final answer. Oh, oopsies. That's how we simplify the square root of negative 4. And so we still have one more step because our x is not isolated, giving us 1 plus or minus 2i. And so this kind of goes with this statement right here. We can get imaginary solutions by solving square roots. And so we're going to practice that with this problem, these two problems right here. So what we do is you can, like the equal sign, add 4 to both sides, giving us 2 times x plus 1 squared equals negative 36. Dividing both sides by 2, we isolate our squared term, giving us negative 18. Now from here, we're going to square root both sides, giving us x plus 1 equals plus or minus. Well, I'm going to simplify the square root of 18 over here because 18 is not a perfect square. It is a perfect square times a non-perfect square. And so what we get is 3i rad 2. And remember, that negative, or that I, is because we are square rooting a negative number. Our last step is to subtract 1 to get x equals negative 1 plus or minus 3i rad 2. Now, the answer for this, oopsies, it does need to look like this because x needs to equal a plus or minus bi. Remember, that's a setup of a complex number. And so that's also why on the previous problem, a plus bi, that form had to show that way. Okay. Let's do one more on this page and then we'll move on. So here we go. We're going to subtract 4 from both sides to get negative 3 times x minus 2 squared equals 27. Dividing by negative 3, so that way we can isolate our x squared term, we get negative 9. We're then going to square root both sides to get x minus 2 equals plus or minus. Whenever we square root a number, we get plus or minus. Well, 9's a perfect square, and it is going to become imaginary. I'm now going to add 2. Now, here we get x equals 2 plus or minus 3i. We don't keep going because 2 and 3i are in different number systems, and we have to combine them to make a complex number. Okay, so there we go. Let's go on to the next page, kind of a little investigation. Okay, so at the right is a partial square representing x squared plus 6x. What we're going to do is we're going to understand about what completing the square is. We're going to mark each rectangle with the algebraic expression it represents. So we have 1x squared. Well, this is the only place where there is one color. I know yours is not color-coded, but you can at least see it on the TV or on the whatever you're watching this on. Then we have 6 x's. Well, there's 6 green bars, so I'm going to make them each x. And so how many unit tiles would need to complete this square? So how many tiles would we need to complete this square? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, now this is a question that I want you to see. What are the dimensions of the completed square? So what are the dimensions of the completed square? Hopefully you get x plus 3 squared. Well, where that's coming from is that this is an x by x. That's how we get x squared. Well, if this is x, well, x times what equals x? 1. And so when I add that all up, that's how I get x plus 3. So my dimensions are x plus 3 times x plus 3, which is the same thing as x plus 3 squared. And so what we can do is we can replace c with 9, because that's how many we needed to make a perfect square, and it gives us x plus 3 squared. So the trinomial we get is x squared plus 6x plus 9, which is a perfect square trinomial, and we've seen that in a previous lesson. Okay, so completing the square, what you're going to do is you're going to find the missing c term in each problem. So I'm going to do the odds first. So what we do is, oh, I totally missed a whole piece of this, sorry. Complete the square. So there is actually a formula where it is b divided by 2 squared. Kind of got mixed up. So what we do is we take the b term and we divide it by 2 and then square it. So what that means is we take 12, divide it by 2, and square it. Now I like to tell people to show all the work because it will help with seeing, or it will help with a previous problem. So we get 36. Then with our next piece, we get -4 divided by 2, square it, which is -2 squared, which is +4. We then have -10 divided by 2 squared, which is -5 squared, which is +25. So those are our odds. I want you to try the evens on your own. Okay, so what we should have done is 20 divided by 2 squared is 10 squared, which is 100. Then we would get -6 divided by 2 squared is -3 squared, which is +9. If you're confused about that, a negative times a negative is a positive. And so what we're getting is, for this problem, -6 squared, which is 36. Okay. And so what you should realize is that C is always, and we don't use the word always a lot, always positive. Now, what we're going to be seeing are very straightforward B values where they're even. It is possible for them to be odd, but we're not going to see them to that extent. Okay, so here we go. Solving by completing the square. What we do is we make sure that the equation is in the form x squared plus bx plus blank equals blank plus c. We're going to move our c term over. Okay, now you find the value that completes the square and put it into both blanks. Factor the perfect square as a binomial squared, and then you solve the equation with square roots. So what we do is we are adding 6 to both sides. That's where that +6 comes from. We then do our b divided by 2 squared, so we get -2 squared, which is 4. So we're going to add 4 here, and we're going to add 4 here. Now you can factor using the big X if you get confused, or what happens is you get x minus 2 squared equals 10. And this is why I told you to show that work, is that this number inside, b divided by 2, will always be your binomial squared. And then we solve, and we get, I'm going to cross this out, oopsies. And what we get is x equals 2 plus or minus the square root of 10. Ta-da! Okay, let's go to the next. Let's do some practice problems. We're going to do 3 more and then call it a day. So we get x squared minus 8x. I'm going to move my c term out of the way. So in doing so, I am going to add a blank to both sides. So that way I, oopsies, what's it called? Don't forget to do it. I'm now going to take my b term, divide it by 2 and square it, which will be negative 4 squared, which is positive 16. So that number is going to go into these 2 blanks. And so this is a perfect square trinomial, meaning we get x minus 4 squared. That's that number equals 9 plus 16 is 25. Be very careful with that step. Okay, and then from here, we solve with square roots. So square root both sides. We get x minus 4 equals plus or minus 5. 5. There's no negative. Add 4 to both sides, giving us x equals 4 plus or minus 5. Well, 4 plus 5 is 9, and 4 minus 5 is negative 1. There are 2 answers. Okay, here we go. Next one, I'm going to move my c term out of the way, so we get x squared plus 6x plus something equals negative 2 plus that same something. So we're going to take our b term, divide it by 2, and square. We get 3 squared, which is 9, so 9 is going to go into those 2 spots. And so we are left with a perfect square trinomial, giving us x plus 3 squared, so that number again goes there, equals 7. And from here, we solve with square roots. So square root both sides to get x plus 3 equals plus or minus the square root of 7. 7 is prime, so we can't simplify. And so we get x minus 3 equals, x equals negative 3 plus or minus the square root of 7. And the last problem that we're going to do, there's no b term to move. So what we have to do, so that way we don't forget it, is add a blank to both sides. We're still going to do negative 4 divided by 2 squared, which is negative 2 squared, which is 4. So again, in both spots, giving us x minus 2 squared equals 4. Square root both sides. We get x minus 2 equals plus or minus 2. Add 2 to both sides to get x equals 2 plus or minus 2. And so x equals 2 plus 2 is 4, 2 minus 2 is 0. For this one, I would have just factored out a GCF and factor. It would have been way easier. Okay. So that is solving by completing the square. What I want you to do is I want you to try example 4, and we're going to go over it the rest in class. Bring your questions to class.